Alright, these polar graphs I want to intro just by doing something very basic with them. There's different techniques you can use to graph these, and I certainly will show you a couple different techniques. But and on page 599 of your book, you can actually just look at that chart and memorize the different equations and what the graphs of those different equations look like. That's not what I'm going to do, and that's not what I'm going to show you, but let's just start off like we would probably any graph that you were graphing for the first time, and let's just plot some points here. Alright, so notice that this is a polar equation, so I've got my r and my theta, which is what we've been talking about. Remember, theta gives me my direction, r gives me my distance. Alright, so I'm going to make a chart, and I'm just going to pick my values for theta and then actually just plot those points, just like any basic graph. So I'm going to use a lot of points here so you can see what's going on. So I'm going to use 45 degree increments. Can't add. $225. Where am I? 270, 315, 360. Alright, so I'm just going to go to 360 because that's what I'm looking at on my polar grid. Alright, so let's just figure out what r is based on the values we picked for theta. So the sine of 0 degrees, if I just plug these in, I get the sine of 0 degrees is 0 plus 1 is 1. The sine of 45 degrees is the square root of 2 over 2, which you probably want to plug in your calculator just to get a decimal approximation since we're plotting these points. So square root of 2 over 2 is about 0.7. So if I add 1 to that, this is just approximation, so let's say 1.7. The sine of 90 degrees is 1 plus 1 is 2. The sine of 135, we're still at the square root of 2 over 2 plus 1, so 1.7. 135 is in the second quadrant where sine's positive, so it's still positive. Alright, the sine of 180 is 0 plus 1 is 1. 225. Alright, now 225 is the square root of 2 over 2, but it's in the third quadrant, so my sine value is going to be negative. So if I do 1 plus negative 0.7, we're looking at around 0.3. The sine of 270 is negative 1 plus 1 is 0. The sine of 315, right, my reference angle is 45 degrees. Fourth quadrant's negative, so I'm back to 1 plus negative 0.7 or 0.3, and then I'm back to where I started from at 360 degrees. Alright, now remember that these are polar coordinates, so we're graphing those just like we did at the very beginning when I introed polar coordinates. So if I'm looking at this, and I used 45 degree increments, so I'm going to split that up just so we can see what's going on here. Alright, so there's my 45 degrees, there's 225 degrees, there is 135, and here is 315. Alright, so like I said, I am literally just plotting points. So if my theta is 0, I'm looking at 0 here, my distance is 1. So I've got that point. Alright, then at 45 degrees, I've got 1.7. So let's just go ahead and mark off 2 here. Alright, so 1.7, I'm going to about right there. At 90 degrees, I'm at 2. Alright, and also remember, none of these values are negative, but if I had an r value that was negative, remember what we do. Let's just pretend this had been negative 2. I would have gone to 90 degrees and then gone the opposite direction, so my point would have been down here. I didn't have any of those, but if you plot points, if you graph these by just picking points like we've done here, remember if you get a negative r value, you go the opposite direction. Alright, let's just keep going. So we got 135, we got 1.7, put that there. 180, we're back to 1. 225, I'm at 0.3. 270, I'm at 0. 315, I'm at 0.3, which is a third of the way to 1. And there we go. Alright, so I've covered all 360 degrees, and I am just going to connect these like I would. And that's what that graph looks like.